Welcome to Geometry PLP, Essential Standard 3, Learning Target 8A, Parallel and Perpendicular Slopes. This lesson should be mostly a review of slope, getting us ready to work with parallel and perpendicular lines. Remember that slope of a line in a coordinate plane is the number that describes the steepness of that line. Any 2 points on a line can be used to determine slope. A couple of terms we use are rise and run. The rise is the difference in the y values of 2 points on a line, or how far it goes up and down. The run is the difference in the x values of 2 points on the line, or how much it goes left and right. The slope of a line is the ratio of the rise to the run. So if we have points x1, y1, and x2, y2, the slope of the line is y2 minus y1 over x2 minus x1. We're going to use the slope formula to determine the slope of these lines. First, we're going to find the slope of AB. We're going to use point A, which is at -2, 7, and point B, which is at 3, 7. Remember that slope equals y2 minus y1, so we're going to take 7 minus 7 over x2 minus x1, 3 minus -2. When I do that, 7 minus 7 is 0, 3 minus -2 is 5. Zeros always make this a little confusing. What is 0 divided by any number? That's always equal to 0. If I have 0 cookies and I divide them between 5 people, how many cookies does each person get? They get 0 cookies. So the slope of line AB is 0. Now let's try AD. A is still -2, 7, and D is -2, 1. Now I want to find the slope. Again, y2 minus y1 over x2 minus x1. This time let's use A as our second point. It doesn't matter which one I use as long as I always use the same one. So 7 minus 1 over -2 minus a -2. That equals 6 over -2 minus a -2 gives me 0. Okay, this time 0 is on the bottom. What is 6 divided by 0? Well, any number divided by 0 can't happen. You cannot divide by 0. So this actually equals undefined. You cannot have a number divided by 0. That's not mathematically possible. I also like to think of it this way. If I have 6 cookies and I divide them between 0 people, how do you divide between 0 people? That doesn't make any sense. So there's no people to get cookies. It's undefined. Let's do the other two real quick. Again, D is -2, 1, and C is 4, 2. The slope is y2 minus y1. So let's go with 2 minus 1 over x2 minus x1, which is 4 minus a -2. That gives me 1 over 6. So the slope is 1/6. If you notice, that's a positive slope, and that goes uphill. AC, A is -2, 7, and C is 4, 2. So we're going to go with the slope. Again, it doesn't matter which one I use first. I'm going to go with 7 minus 2 over -2 minus 4. And I have 5 over -6. This is a negative slope. We would say this as -5/6. And if you notice, AC goes downhill. Line AC goes downhill. That's a negative slope. We can also use the slope formula to determine slope without having a graph. All we need is the points. So again, the slope formula is y2 minus y1 over x2 minus x1. So let's make this r1 and this r2. So y1 minus y2 over x2 minus x1. I think I said that wrong, but you know what I mean. Negative 1 minus 1 is negative 2. And 2 minus 3 is negative 1. Now remember, a negative over a negative is a positive. So this becomes a positive 2 over 1, or 2. This line has a slope of 2. That's a positive slope of 2. When we're doing slope from a graph, remember this is the same graph we looked at before, it's really actually easier to just say rise over run than use the full slope formula. If I'm going from A to B, I have AB. My rise is 0 because I do not go up or down. And I go 1, 2, 3, 4, 5 to the right. So my slope is 0. That's the same thing we got before with the formula. Line AD. My rise is 1, 2, 3, 4, 5, 6. Negative 6 because I went down from A to D over 0. Again, I can't divide by 0, so that's undefined. DC. My rise, I go up 1, so that's positive 1, over my run, which is 1, 2, 3, 4, 5, 6. That's a positive 6 because I went to the right. So my slope is 1/6. Actually, I don't need to simplify that. That is just 1/6. And finally, AC. My rise is 1, 2, 3, 4, 5. So I went down 5. It's negative 5 over. I went from left, if I go from left to right, from A to C is 1, 2, 3, 4, 5, 6. Negative 5 over 6. If you remember, that's negative 5, 6. Same as last time. Let's point it out here too. If I were to go from C to A, if I go from C to A, my rise is 1, 2, 3, 4, 5, but it's a positive 5 because I go up. And if I go from C to A, it would be 1, 2, 3, 4, 5, 6, only it's a negative 6 because I'm going to the left. That again is negative 5/6. So it doesn't matter which way I go, as long as I measure my rise and my run in the same direction, like always from C to A, or always from D to C. This is a real life example of using slope. Slope has different meanings and different problems, and it's used a lot to figure things out in the real world. So Justin is driving from home to his college dorm. At 4 p.m., he is 260 miles from home. At 7 p.m., he is 450 miles from home. Graph the line that represents Justin's distance from home at a given time. Find and interpret the slope of the line. So we have to, in real life problems, we have to label our axis. So let's go ahead and make each one of the x's a time. So 1 o'clock, so this would be 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. And at 4 o'clock, he's 260 miles. So let's make these, we're going to have to go to 500, so let's make these, let's go with 50. So 50, 100, 150, 200, this one would be 250. So at 4 o'clock, he's just above 250. And at 7 o'clock, he's 450. So let's go 3, 4, 4. This one's 450. So at 7 o'clock, he's pretty much right at 450. I can draw a line to connect those. If I go from here to here, and I can extend it in the other direction. This is what my line's going to look like. Hopefully it's a perfectly straight line when you draw it, but that is my line that represents his drive time. So it's probably not exactly right. I'm guessing when he left home, he was actually at home, but it's close. What does this slope mean? This slope is how many miles. So if I wrote out slope, it would be how many miles over how many hours it took him to get there. So what is the meaning of my slope? It's miles per hour. So the slope equals the speed that he's driving. Okay, we're going to talk a little bit about relating slopes, but before we have to do a little review. What is a reciprocal? A reciprocal has to do with fractions. If I have a fraction of 1/2, if I want its reciprocal, that would be 2 over 1. It just means I'm basically turning the fraction upside down. If I have 3/4, the reciprocal would be 4/3. What if I have 25/6? If I turn it upside down, the reciprocal will be 6/25. When we're talking about numbers, what does it mean to be an opposite? If I use the number 2, let's not use the number 2 because that's our example here. If I use the number 4, what is its opposite? That means you change the sign. It becomes a -4. What if I have a -1/3? The opposite would be positive, so 1/3. You either take away the negative sign or add a negative sign. So at this point, I'd really like for you to pause your video for just a moment and find the opposite reciprocal of the numbers below. Go ahead and pause it, make sure you've tried it, and then come back and we'll go through them. Finding the opposite reciprocal of each of these. If I have a positive 5/8, the opposite is going to be negative. The reciprocal is upside down, so this would be -8/5. For 2, the opposite would be negative, and then we have to think of 2 over 2 being 2 over 1. So that means the opposite reciprocal is -1/2. For -3, it's going to become positive. The reciprocal is 1/3. So opposite reciprocal is 1/3. -5/7 means my opposite reciprocal is going to be positive. So 5/7. 1/4. Opposite reciprocal would be 4 over 1. And remember, that's just the same as 4. That's just a little review to help us with the definitions we're about to use. We have slope of parallel lines and perpendicular lines. In a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. You notice I said 2 non-vertical. Why do we stress that? What's the slope of a vertical line? Well, remember, a vertical line, a straight vertical line, has a slope that's undefined. So I can't have a slope equal to undefined. So any 2 vertical lines are also parallel. So basically, any 2 lines with the same slope are parallel. Now, perpendicular lines, 2 non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals of each other. So if I have a slope of 1/2 and I have another line with a slope of -2, those are going to be perpendicular lines. Let's just look at one quick example. We have 3 lines on this graph. I know it's a little hard to see, but we have 3 lines on here. I want to see if they're parallel. So let's look at K1. This is our line right here. We can use these 2 points to use the slope formula and find it, although I'm going to do it the quicker way and just do rise over run. So to go from this point to this point, I go up 1, 2, 3, 4, 5. So that's a positive 5. And to the right, 1, positive 1. So the slope of K1 is 5. K2, let's look at this line that's in the middle. I'm still going to use these 2 points, but again, I'm going to do rise over run. So I go up 1, 2, 3, 4, 5, 6. So I went up 6. And I went over 1. So it's 6 over 1. The slope of K2 is 6. And finally, K3. So I'm going from this point to this point. I go up 1, 2, 3, 4, 5, positive 5. And to the right, I go 1, so positive 1. The slope is 5. So because K1 and K3 have the same slope, they're parallel. And because K2 has a different slope, it is not parallel to either of the other lines. That is how we determine whether we have parallel lines. We can do the same thing with perpendicular using the opposite slope. That's it for this lesson. Do the practice associated with this, and then we'll talk some more about parallel and perpendicular lines.